Welcome to the APD Process session on Getting to Go Live. This is the 7th module in the APD Process training series. If you have reviewed the modules in the order presented on this slide, then by now you should have a good understanding of the APD process and requirements. It is at this point in the System Development Lifecycle that you are ready to test the system and implement what has been developed. These are the acronyms used in this module. Take a minute to review the slide. In this session, we will review project milestones that are critical to a successful full system rollout. A test plan is a required element of the IAPD. We will review the components that make up a sound test plan. We'll discuss the different types of testing and the importance of a diverse and well-trained test team. User acceptance testing and the system pilot test are dependent on each other. We'll look at the details for each testing phase. A piece of that dependency is in regard to the new FNS testing rule published in January 2014 and effective March 2014. This rule now requires concurrence from FNS to move from one phase to the other. Finally, go-live criteria will be explained and we'll make note of the benefits of using the FNS System Integrity Review tools. The state agency, stakeholders, and sometimes multiple contractors have worked hard and all the system development work is done. You are now ready to implement the system you have designed. But, do you just flip a switch and presto? Unfortunately, no. There's much that needs to happen before that magical moment. Testing starts before launch and continues through safe landing. In other words, testing starts with the first piece of code developed and continues internally until UAT. Then, internally and externally through pilot. So let's get started on the steps needed to ensure your full implementation is successful. The 2008 Farm Bill and final regulations at 7 CFR 277.18 required that the state provide a complete test plan to FNS prior to the start of the testing phase. Preliminary plans may be submitted based on information available at the time of the initial IAPD and completed in more detail during the appropriate phase of the project. There are multiple rounds of testing during development. Adequate testing includes holding the system developer responsible for delivering a product that has been thoroughly tested in-house and is ready for the state's user acceptance testing. Well-planned and proper testing by your developer can prevent the perfect storm. The test plan should describe how all system testing will be conducted in order to verify that the system complies with program requirements, design specifications, performance standards, usability, capacity, and security. Before we talk about various types of testing, let us first look at the impacts of the newly required test plan. FNS expects the new testing requirements to have minimal impact on the state's workload. Most documents now required during the advanced planning document process are already prepared during the customary system development lifecycle. System testing is a part of the project and risk management efforts. When implementing major systems, states already include plans for testing, small-scale pilots, and some form of graduated rollout. FNS intends to use a proactive analysis of state test plans. Results from the user acceptance test and pilot test will be evaluated from a system perspective as well as a program perspective to determine whether their outcomes can be considered successful. What is new are the requirements for FNS review and approval of the results of the user acceptance testing and the pilot test. Approval of the UAT results is a condition for continued federal financial participation and allows the state to move from UAT to pilot in a production environment. Once the pilot is complete, the state must provide documentation to F&S of the pilot evaluation. Approval from F&S of the pilot results and to implement the system more broadly is a condition for continued FFP. Now that we have discussed the impacts, let's look at the components of a well-developed test plan. At a minimum, the test plan shall address the types of testing to be performed, for example, unit testing or system integration testing, your test team, who makes up the team, its organization and associated responsibilities, how the test database will be generated, for example, how much data may be converted, and the development of sound test cases that are clear and lead to expected results. In addition, the test plan should have a well-defined schedule for testing that allows adequate time to test, review results, and retest if needed. Be sure a scheduled acceptance test includes functional requirements testing, how error conditions are handled, and security testing. You will need to consider how test results will be documented, demonstrating goals achieved. Most importantly, specific test results should be defined explaining how they will be met before the state may exit the testing phase. These are known as go, no-go decision points. And finally, a contingency plan component should be included which identifies alternative strategies to be used if specific risk events occur, such as failure of test results to support a decision to proceed to the next phase of the project. Examples of contingency strategies include alternative schedule activities, staffing plans, and emergency responses to reduce the impact of risk events. When evaluating the plan for system testing, pilot, and implementation, F&S will also consider questions such as the following, if not specified in the state's planning documents. Who has the responsibility for verifying the test results, and what is the sign-off process which will document that the go, no-go criteria have been met? What scenarios are being tested during UAT? Are these scenarios scripted? Who identified these scenarios to be tested and developed the scripts? Is your test team defined? When errors are found, how are they prioritized? Are fixes regression tested and validated by UAT test staff? How is the conversion process being tested? Will the new system become the system of record during the pilot? What is the plan for rolling the new system out to the rest of the state? Is it a phased rollout? We have covered what a test plan should encompass, so now let's get into testing details. While there are various types of testing throughout the system development lifecycle, there are three major testing phases that occur. First, there is testing during development. Second, with users, known as user acceptance testing. And finally, testing happens again during pilot. We will look at the specifics of each of these phases. There are three key types of testing that occur during development: unit or component testing, benchmark testing, and systems integration testing. These are done by your developer to ensure the system is ready and functioning for user acceptance testing. Let's look at what happens in each of these types. Unit component testing. The goal of unit testing is to isolate each part of the developed application and show that the individual parts are correct. As each component or logical unit of work is developed, it should be tested for its functionality. As a result, unit testing affords several benefits, such as finding problems early on and facilitating change. A very large percentage of errors can be found at this level and corrected. Unit component testing continues throughout development. Benchmark testing. The purpose is to simulate operations to determine if the system will meet specified criteria for sizing, performance, and capacity. This is a normal part of the application development lifecycle. Benchmark testing is a team effort that involves both application developers and database administrators. and should be performed against your current application in order to determine current performance and improve it. Systems integration testing. The purpose of this test is to verify that the complete system performs as designed. This is done by the development team testers on a complete system in an environment matching that of the production environment as closely as possible. At this point, if all seems to fit and operate as designed, can you guess what stage comes next? User acceptance testing, or UAT. This is where the rubber meets the road. You will have to make a major commitment of your resources to this process. It is a crucial part of the development, integration, and testing phase. UAT is conducted prior to pilot and implementation and is the point at which the state agency accepts the system. Acceptance testing shall include functional requirements testing, error condition handling and destructive testing, security testing, recovery testing, controls testing, stress and throughput performance testing, and regression testing. A successful UAT would be considered a go, no-go decision milestone in getting to go live. UAT is testing done by end users. Your development contractor testers should work with a specific group of end users early in the project to define system criteria for meeting user needs, incorporate them into an acceptance test plan, and create detailed test scripts. UAT should be conducted in an environment as similar to the production environment as possible, but should be separate from the development and production environments. System stress and performance testing should be a part of acceptance testing. The testing methodology must be rigorous and results must be documented thoroughly. Let's look at the goals of UAT. UAT will help validate that the system meets all F&S required functional requirements. Most notably, does the system make proper eligibility decisions and issue benefits correctly? Also, UAT will help assure that any additional functions as specified in your design document are operating as planned. UAT provides end users their opportunity to ensure the logic works. It is during UAT where defects and bugs will be found, and the development team must help identify why the errors are occurring and resolve them before the project goes any farther. In addition, UAT provides the best opportunity to evaluate and compare the new system's efficiency versus the system and the business processes it replaces. It will also give you an indication of how easily staff can adapt to the new business processes, help you determine what is crucial for training staff, and what kind of learning curve to expect. There are two key elements that can make or break UAT. The first is the test plan. The state should develop a formal test plan for UAT that includes real-life scenarios. This is where the interaction between the development testers and a specific group of end users is important. The test plan should detail all steps of the testing process and include all functions to be tested, inputs, and desired results. Users should test the system using scripts that document the path to an error, so it can be replicated in order to be corrected and the fixes can be validated in UAT. The second key element of a successful UAT is the test team. The right test team must include users, IT staff, and management staff, as well as trainers who will be prepping to train staff for the pilot test. In addition, you will need to assign a test leader who has the authority to stop the UAT should a critical error occur. While your development contractor must not run the UAT, they must be available to answer questions should major errors or defects arise and help resolve them. UAT and contracts. Why talk about contracts now? Your contract will help you manage your milestones, especially those that require F&S approval. It is the best way to control the development and testing processes, ensuring results according to your approved plans and designs. These specific items should be part of your contract with your system developer. Go, no-go decision criteria should be well defined. By that, we mean specific and measurable, with results that will need to be met before the state agency exits the testing phase. Examples of specific and measurable criteria to achieve a go could be no critical errors, such as are benefits determined correctly, or no errors that affect the logic or outcome of the process or function. For example, no major workaround is needed to achieve the required function. The contract should also identify staff responsible for verifying the defined go, no-go criteria have been met and approving the results. Therefore, the approval of the results of the UAT and pilot should be explicit in your contract with the developer. In addition, your contract should be explicit in regard to regression testing. This is any type of software testing which seeks to uncover regression bugs. This should be conducted throughout all system testing and most importantly throughout UAT. Okay, what does that mean? Regression bugs occur whenever software functionality that previously worked as desired stops working or no longer works in the same way that was previously planned. A common method of regression testing includes rerunning previously run tests and checking whether defects that were fixed have reemerged. FNS may require any or all of these tests to be repeated in instances where significant modifications are made to the system after these tests are initially completed, or if problems that surface during initial testing warrant a retest. FNS reserves the right to participate and conduct independent testing, as necessary, during UAT and at appropriate times during system design, development, implementation, and operations. Your statement of work for a development contractor and contract should explicitly require regression testing to be conducted throughout all system testing and most importantly throughout UAT. As mentioned at the beginning of this session, language in the 2008 Farm Bill and final regulations require adequate system testing before and after implementation for major systems changes. The state agency must provide documentation of the results of performance and user acceptance testing to FNS. Keeping FNS apprised throughout UAT with regular communications and documentation will let us review the final results based on more informed decisions. FNS approval of the final UAT results is the basis for continued FFP. UAT has been completed. FNS approved the results, and you are on schedule for a system launch. But wait, what happens next? The pilot test. Who are these people? NASA test pilots. And how important is thorough testing to them? We're going to talk about the next step in getting to go live, the pilot test. This is the last milestone before a full system launch. Pilot testing may prevent costly mistakes and can begin after UAT results are approved by FNS. Pilot testing occurs when a fully functional prototype system, all operating components, is available for testing in a live production environment, but before statewide implementation. Pilot is the best opportunity to identify defects in either the system or the implementation approach before they become costly large-scale problems. This is because you can modify errors, bugs, and glitches before the system rolls out to all users. State agencies must operate pilot projects until a state of routine operation is reached with the full caseload in the pilot area. The pilot also needs to include operating all components of the system in a live environment. Pilot is not simply the first phase of rollout, nor a formality to proceed. For example, a quick run of the system for 2 weeks in one local agency. The main purpose of the pilot test is to catch potential problems before they become costly mistakes. Don't let the schedule override all other considerations. A date on a piece of paper with the word rollout next to it is not written in stone. It is written on paper. Don't hesitate to stop or extend the pilot if there are indications the system is not ready for full use. The goal of the pilot test is to achieve a high probability that the implemented system will meet approved IAPD objectives and is a key milestone in project development. The main goal is to operate a fully functional system in a live environment. Then evaluate and ask these questions. Did you get what you asked for? Does it look like and act like you expected? Is something missing? Are the reports working or screen functionality not logical? Is the system ready to roll out? Is it free of critical errors? In other words, the pilot test is a key milestone in project development and occurs before statewide implementation. If you are ready for statewide implementation, then your testers have completed their mission. In planning for the pilot test, the state agency should ensure that the test, at a minimum, includes the following elements. Performance test, to simulate system operation and thereby project whether the system will meet the criteria in the IAPD for sizing, performance, and capacity. Systems test, to ensure that each component as delivered by the contractor or state IT staff operates in accordance with the design specifications. End-to-end test, to ensure that the interactions between each component and interface perform in accordance with the design specifications. The pilot should allow sufficient time to fully test the system. If you schedule a short pilot, only a couple of weeks, with no time afterwards for evaluation or to correct final issues with performance or functionality, then it is not a pilot. It is just the first stage of rollout. Be prepared to do it right. Remember, the rollout date is written on a piece of paper, not in stone. You will need adequate time to reevaluate any changes you may have made and perhaps retest before you present the results of pilot to F&S. These are some of the characteristics that help define your pilot. The pilot sites should contain as many variables as possible. You will want to look at geographic preferences, how many counties or local agencies. What is the caseload in those locations? Might you need to add an area for more accurate representation of your current operating environment? How adaptable are the staff in these areas and what kind of user skills do they have? Will they be an accurate representation of your staff demographics? Pilot testing will also help you answer some of these questions. Is the IT infrastructure able to handle the new system? Were the sites ready? Is user training effective? What is the learning curve? Do the new business processes work? Did you realize any changes, positive or negative, to efficiencies? Normally, the pilot test involves parallel processing of data through the current and the pilot system, then comparing the results. States should work to resolve any discrepancies found at this point. A contingency plan is a very important component of the test plan. All stakeholders must have an opportunity to provide input to the contingency plan in advance of testing, helping to define comprehensive go, no-go criteria. A contingency plan will address such concerns as: what is the impact of a short or long-term delay? A delay or a critical error could affect the user training schedule and the logistics for training locations and trainers. Perhaps adjustments would need to be made to workload in preparation for rollout. What about costs and funding? How is the budget doing? What would the state do if funding was no longer available? Might you need to roll back to the current system? What is the status of the current system's maintenance and operations contract? Would you need to extend if there were critical delays? These are all issues that require the stakeholders' attention. As you can see, contingency planning is a must. As mentioned at the beginning of this session, language in the 2008 Farm Bill and final regulations require adequate system testing before and after implementation for major systems changes. The state agency must provide documentation of the pilot evaluation to FNS. Keeping FNS apprised throughout pilot testing with regular communications and documentation will let us review the final results based on more informed decisions. FNS approval of the pilot results is needed to implement the system more broadly and is a condition for continued FFP. Remember, FNS intends to use a proactive analysis of state test results. The pilot test evaluation will be assessed from a system perspective as well as a program perspective to determine whether the outcome can be considered successful. Now let's talk about training your staff in preparation to use the new system during pilot and after, as well as what can make or break training on a new system. We have all been to this one, the snoozer, or this one, divide and conquer. And the end all, what? I've never done it this way. Sometimes training is done by state and local staffs that participated in UAT and are considered to be super users, or training can be accomplished by contracted staff. However training is conveyed, it needs to be engaging, hands-on, and at a level for your common staff user. What makes training effective? Remember that UAT is an opportunity to test your training curriculum. Learn from those lessons and incorporate them in your training plan. Having a good resource plan is key to providing training that is both just in time, in other words, not months before pilot or rollout, and is hands-on. Be sure you have an environment where users are truly using the system. In addition to having well-informed trainers that can reach their audience, early planning for training facilities and equipment is a must. The where, when, and how. Proper training will get staff familiar with the new system and prepare them with the knowledge and skills they need for your pilot test or rollout. There will be training after rollout as well, for new users and refresher courses for those needing extra training. Also, when enhancements are made to your system, this may trigger additional training for staff. What you are aiming for in training will give users confidence with the new system, empower them to ask questions as they continue to learn, and enable those capable to assist others. You want to be sure your training engages those in attendance and they take away valuable skills learned for use with the new system. User guides and tip sheets are great aids and can be used to prepare for the pilot test. These can also be used in other geographic areas as they get ready to implement the new system. We have discussed test plans, UAT, pilot testing, and training your users. So now we are going to switch gears just a bit. How can you be sure that your system as built processes correctly and meets your requirements as defined and approved? There are several methods. One method is called independent verification and validation, or as some people refer to it as 4 and 5. IV&V is a review process performed by a third party independent of the project. It may be done by a contractor, or some states do handle this effort internally. What is of utmost importance is the process should be done independently of the project team. Verification is determining that the system is built right, such as, does the product fulfill the requirements placed on it by the previous steps, and are sufficiently correct to support the next step. Validation is determining if the right system is built, such as examining the complete system application to determine if all stakeholders' requirements have been met as defined. The other available method is the FNS System Integrity Review Tool. This review tool was designed so it can be used during pre- or post-implementation reviews conducted by state and/or federal reviewers. There are tools specific for both SNAP and WIC and will walk the reviewer through an entire system operation according to federal requirements. State agency staff should complete the tool and validate system functionality before too much time and effort is spent on UAT. It is due to FNS before UAT is complete, such that there is sufficient time for FNS to validate the results prior to the go-no-go pilot decision date. The tool also has a section on the test plan that the state can reference as they develop their test plans. The System Integrity Review Tool will assess the capabilities of the system and validate that the FNS program's policy as well as system functional standards are correctly operating. Also, you can evaluate if the approved IAPD requirements, project goals, and objectives were met. You will also be able to determine if the equipment and services FNS provided with funding are being properly used to support FNS programs, and if equipment inventories are documented and accurate. The review will also aid in determining the actual cost and cost effectiveness of the system, such as assuring that the cost did not significantly differ from the most recently approved APDU, and that the approved cost allocations in the budget were applied correctly. In addition, you will be checking that the system satisfied requirements in these areas: accountability, management, user training, documentation, and security. Used at post-implementation, it is a critical look at whether the training was effective and the workers are functioning well, and if the contractor has fixed any outstanding issues. All aspects of the system must be validated and/or resolved before the warranty period expires. FNS may conduct pre- and/or post-implementation reviews on site. If so, we will be providing you with the review tool to complete before we come on site. What it is not. It is not a certification process. We are asked this question often, so it bears repeating. FNS does not certify systems. So, if all goes well with your system integrity review, UAT, and pilot, it should be a time for this. Go live, a full system launch statewide, happy users, recognized efficiencies, and the satisfaction of a job well done. Not. This. There is no finger pointing. You were prepared. You had a detailed test plan, allowed sufficient time to test and retest, used the System Integrity Review Tool, and communicated results with your stakeholders and FNS. The end result is Go live, a full system launch statewide, happy users, recognized efficiencies, and the satisfaction of a job well done. Now at this point, you should have a good overview of what it takes to get your system turned on, so to say. In summary, getting to go live involves many detailed steps. We have reviewed these project milestones: what a test plan must include, the types of development testing, how to prepare for and conduct a UAT. This includes your UAT environment, trained testers, well-developed test scripts, and regression testing. The requirements of the new testing rule and how they apply to UAT and pilot. Results of the UAT must be submitted to FNS for approval before the state can move to pilot, and results of the pilot must be approved before the system is rolled out statewide. What characteristics make a good system pilot? Location, demographics of users, and being fully operational with a full caseload in the pilot area. Be prepared to devote time to a well-run pilot. It should be an extension of system testing in the real world. How well-defined go-live criteria allows the state to monitor testing and move to the next phase, as well as being able to halt testing if criteria is not met. And finally, we discussed system integrity reviews, how to best utilize the tool pre-implementation to be sure your system is ready for UAT, and its benefits used post-implementation to assure the state that the system has met all of its requirements before the warranty expires. How do you feel? Are you ready to engage in this step of your system development? Getting to go live is about being prepared up front with good testing plans for UAT, pilot, well-defined go, no-go criteria, and a contingency plan. Applying these essential steps can assure your system is ready for go live. Congratulations on completing Session 7, Getting to Go Live. Your next goal is the final session in this series, Project Management. Please contact us if you need more information or assistance.